Okay, so today we're doing 15.2, constructing geometric sequences. Yesterday we were dealing with them and you were just finding out the next couple of terms in the sequence. Today you're actually going to be constructing the general idea of them. Okay, they're going to be that recursive and explicit rules. Okay, so remember what that is. Okay. So, constructing recursive and explicit rules for given geometric sequences. To write a recursive rule for a sequence, you need to know the first term and a rule for successive terms. Okay? So, example 1 here, remember you're writing all examples and all headings. Okay? It's the example 1 is writing a recursive rule and an explicit rule for each geometric sequence. How come it didn't move? Oh, my bad. Okay. So, makers of Japanese swords in the 1400s repeatedly folded and hammered the metal to form layers. The folding process increased the strength of the sword. The table shows how the number of layers depend on the number of folds. So the table shows how the number of layers depends on the number of folds. Okay, you can see the number of folds, number of layers. For the first layer, they have one fold and 2 layers. 2 folds, 4 layers. 3 folds, 8 layers. Okay. It says, write an explicit rule for the sequence by writing each term as a product of the first term and the power of the common ratio. Remember how we figure out that ratio? R, right? You take the second term, you divide it by the first term. Okay? I'm going to take the second term, divide it by that first term, and my common ratio is 2. Okay? So now, first off, it did say that to write this recursive, so it's first asking us to write an explicit rule. Okay? Now, so to do this explicit rule, so I'll put explicit rule, okay? All right. You need to take the way the generalized form looks like this. We're going to have an f of n is equal to. Now, again, just like writing a recursive rule, for the explicit rule, you need to know that first f of 1, okay? And our f of 1 here is 2, okay? So then we're going to take that 2 and we're going to multiply it by that ratio, okay? By that ratio, and instead of, and we're going to use a power instead because it's geometric, means it's increasing exponentially type of deal, okay? So the way that you do this is you put it to the n minus 1. That is our very first explicit rule, okay? Just take a look at that and see how I did that, okay? So for the general idea, gen form, okay? The gen form of it looks like this. You're going to have your f of n, and you're going to have it equal to f of 1 times that ratio to the power of n minus 1. That's the general form of it, and this is for explicit rule, general form of explicit rule, okay? So that's the general form of explicit rule, okay? All right. Here, whoa. Okay, now we're not done. They want us to write, now we need to write a recursive rule. Okay, so now to write a recursive rule. Okay, so this recursive rule, all right, again, you got to make sure you know this ratio here. So you got f of 1, remember you got to define your f of 1. F of 1 equals 2, right? Now we got to write our general f of n. All right? And unlike our explicit form, okay, what we're going to do is we're going to have this f of n minus 1, okay? And what is it increasing by? It's being doubled every time, times the ratio, that ratio, okay? So the general form, all right, the general form for recursive rule looks like this. You're going to have an f of 1 equals something, okay? And then what you do is you have your f of n is equal to f of n minus 1 times that ratio r. That's it, okay? It's not that difficult, or well, I don't want to say it's not that difficult. It does get confusing, especially when you've been doing it for so long. Okay, you'll start mixing up the rules, so just take your time and make sure you do this real slow like. All right, so, right, here's the other idea. Okay, so we're first going to write an explicit rule, and then we will write a recursive rule. I find that the explicit rule is a little bit easier for me to deal with. All right. So again, remember that general form over here. So what I'm going to do is I'm going to quickly write what that general form looks like. That general form of for an explicit rule. This is explicit rule general form. Okay. So we got that f of 1 times the ratio to the power of n minus 1. Okay, and I'm going to go ahead and write the recursive general rule over here, right? We're going to have an f of 1, and then we're going to have a f of n equals f of n minus 1 times whatever that ratio is, okay? So the first thing we need to figure out is our ratio, okay? Our ratio r, okay? All right, so we take two consecutive terms, we take the second term and divide it by the first term, okay? And as we can see, it's 3. All right, so using the explicit rule first. I don't know why I'm starting with the explicit rule, and I guess it doesn't really matter. So we got our f of n equals, what's our f of 1? Our f of 1 is 5, okay, times the ratio to the power of n minus 1, okay? And that'll make it fun. You'll find, and remember what our explicit rule lets us do. It makes us, we can find the 20th term without having to find the 19th term, okay? Unlike what this recursive rule is going to do. So first we have to define our f of 1, right, for recursive. All right, our f of 1 is 5. Now we come over here and we write our f of n equal, okay, so, sorry about that, I had a phone call. All right, f of n equals, okay, I don't know what I've done with my pen, so I got to find it, but I'm not too worried about it. F of n equals, and I'm looking at my recursive rule general form, right? So f of n minus 1, and what times my r, which is 3. Excellent. So it shouldn't cause you too much problem, at least in the beginning here, okay? So now that we've done this, okay? All right, this is your turn, so I want you to write a recursive rule and an explicit rule. I kind of like to start with the explicit rule, but that's okay. Either way, it does not matter. And look, remember to do this down here. So you got 5 and 6 to do. Okay, so I'll leave this here for a second. I'll move it down. Remember to pause the video while you're doing this. Excellent. Okay, moving on. All right. Deriving the general forms of geometric sequence rules. Okay, so example 2. Use each geometric sequence to help write a recursive rule and an explicit rule for any geometric sequence. For the general rules, the value of n are consecutive integers starting with 1. And what they're talking about is they're talking about just the n. So you got 1, 2, 3, 4. Okay, which kind of contradicts what Algebra NACE is doing, where they were starting with 0 for some reason, which I disagreed with. But that's okay. All right. So, okay. So the first thing they're going to do, they got these terms: 6, 24, 96, 384, 1,536. Okay. But we first need to find the common ratio. Okay. And look, they've done it for you right here. Okay. They've already done all this. And they're talking about the algebraic part of it, okay? F of 1 is 6, F of 2 is 24, F of 3 is 96, so on and so forth. They take any two consecutive numbers, divide the second one by the first one. Did you say that right? I just want to make sure I said that right. You divide the second one by the first one, yes, and you get 4, all right? So what they're trying to get you to do is trying to derive this idea here. Is really what they're trying to do is to get you to understand this, which I already gave you that, okay? So you really don't have to worry about that. This is really the part that I'm concerning with, that you're able to write these recursive and explicit rules. Okay, and again, down here, they give you the recursive idea. Okay, sorry about that. I should move that out of the way. Okay, and remember, what did I make my mistake on my last one? I didn't put right for r is greater than or equal to 2. Okay, because they've already defined 1, so you don't need 2. I mean, you don't need 1. Okay. All right, here's another one. I guess I can actually work this one out. First off, find the common ratio. All right, so I take the second term, I divide it by the first term, and we can see that this is 3. Okay, so what they're actually wanting to be doing here is 4, 12, 36, and 108. Okay, is my f of 1, my f of 2, my f of 3, my f of 4. All right, and there's my dot, 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 right? Okay, so now that they actually want us to write a rule. Okay, so here comes our recursive rule. Now, we already know the general idea of our recursive rule. We need an f of 1, and then we need an f of n. Then f of n is going to be f of n minus 1 times that ratio. Okay, so all I need to do is come over here and start that. So my f of 1 is equal to 4. So now I can write my recursive rule, f of n. Right, recursive rule. Good, I'm doing the right one. So f of n minus 1 times that ratio of 4. Now, the explicit rule. The explicit rule I sometimes find a little bit easier to write, at least for me. But remember, it's not going to look like that. It's not going to look like the recursive at all. Okay, so I'm going to go ahead and write the general algebraic idea of the recursive rule. So you got your f of n is equal to f of 1 times your ratio to the power of n minus 1. And that's all you got to do is come over here and rewrite that. Okay, so f of n is equal to f of 1 is 4 times my ratio of 3. Remember, whoop, what did I put over here? Did I do that wrong? I did. This isn't supposed to be 4. This is supposed to be 3. Whoops. Okay, because my r is 3. Okay, and then 3 to the power of n minus 1. Okay? All right, because what they need to do is they need to start at a base of some sort, grow from there. Because if you just put it to the power of, it wouldn't grow properly. All right, so here you go. I want you to do this. Okay, here's 9, and I don't think there's a 10. Nope, there's not. So just do 9 here. Again, you're doing these on your whiteboards, so you can show them, bring it up to me and show me that you did it. Okay? All right, constructing a geometric sequence given 2 terms. Let's see what my time looks like. Excellent. Going a little too slow. All right, it says here, write an explicit rule for each sequence using script notation, subscript notation. Okay? All right, photography. The shutter speed setting on a camera form a geometric sequence where a sub n, that's subnotation, where a sub n is the shutter speed in seconds and n is the setting number. The 5th setting on the camera, okay, so I'm going to write that down. The 5th setting on the camera is 1/60th, okay, and the 7th is 1/15th. Now, we can't find a ratio here, but what we can do is we can kind of find a ratio of some sort. Now, your first thing is going to be, you're going to do this. You're going to find out, okay, so what do I got to do to 1/60th to get it up to 1/15th? And as most of you probably look at that and go, oh, I just got to multiply it by something. Okay, so I'm going to grab my handy-dandy calculator and do that. I'm going to pause the video so you don't have to waste. All right, that's 4. Okay, but that's... And the first thing you want to do is you're going to want to divide by 2, but that's not what you want to do. You don't want to divide by 2. What you want to do is you want to take the square root of 4, which equals 2. So your r, and that equals your r. So your r is 2. So now we know our r. So now we know the 6th term. Okay, and all we got to do is just divide that. We're multiplying it by 2. Okay, when you multiply that by 2, it becomes this. Now I'm going to go backwards, so I need to find the 4th, the 3rd, the 2nd, and then the 1st, and then I can finally write my explicit rule. Okay, I'm going to write my explicit rule up here, f of n. All right, so we are going backwards now, so I want to make sure that I do this correctly. So to do this, we got to double this, so that is 1/20th. Okay, you got to double this, which is 1 over 240. We got to double this, which is 1 over 480. And then last but not least, we got to double that, and that is 1 over 0, 6, carry the 1, 190, 1 over 960. Okay? 1/960th. Now, we have to write our recursive rule, because our f of n, it should be that. So our f of n is equal to, again, I'm going to write the general form real quick, times the ratio to n minus 1. So that over here is going to make, ours is going to be like this, f of n equals, and my ratio is 2, okay, but my f of 1 is 1/960th, okay, times my ratio of 2 to the power of n minus 1. Okay, not too bad, right? You guys should be able to do that. All right, let's get on to something a little bit harder, all right? Okay, viral video. You tell a number of friends about an interesting video you saw online. Each of those friends tell the same number of friends about it. This pattern continues, and there are no repeats in the people told. The number of people who hear about this video through you form a geometric sequence. There are 256 in the 4th, okay, and in the 6th, we have 4,096. Now, again, I'm going to go ahead and find out what that difference is. Okay, not that difference, but what that ratio is. So I'm going to take 4,096. I'm going to divide it by 256, and I'm going to come up with 16. but I got to take the square root of 16. Because remember, it's going to a power. It's growing exponentially. So to take the square root of 16, and everybody knows that that is 4. So really what I'm multiplying is I'm multiplying by 4. So 256, and as a matter of fact, you know what? I don't even care about that. I was going to figure out the fifth term, but we don't really care about that. We don't even need to know it. We need to know the third, the second, and the first. Because then we can write our explicit rule. Okay, and again, I'm going to write the general formula times cursive to the power of n minus 1. Okay? All right, so we're going to have our explicit rule here and what it actually is. So f of n is equal to. So I'm going to take 256, divide that by 4. That's 64. If I hit enter again, I wonder if it'll divide it again. Nope, divide by 4. That's 16, and then divide by 4, and that's 4. So you got 4 to the power of 4 n minus 1. Okay? Now, granted, you may want to combine that. Okay? And I would not be hating on that, but I would not do that right at this point in time. Okay? Just leave it the way it is, because that's the way we like to look at it. Now, I know that when you hit algebranation, they're going to be simplifying and doing all that other fun stuff. So don't worry about that. Just leave it in that form. All right. So there we go. So this is your turn. Write an explicit rule for the sequence using subscript notation. Okay? And what they're trying to do is using subscript notation is really over here. This is n sub 1. This is, a sub 2. This is a sub 3. All right? You don't have to worry about that too hard. What you do have to worry about is probably on your homework, which they'll show you. You'll mess up the first one. Don't worry about that. All right. So here, remember again, pause this right here so you can work on this. And there it is. Do HRW 1 through 23 odds only. Remember to show all your work that is to be turned in. All right. All right. That's the end of the video.